Hello, welcome to Lookup. We built Lookup to solve a fundamental problem, the ability to query videos like databases for things like objects, counts, events, scenes, actions, and many more. Lookup allows you to ask your video anything. We have built a platform that allows anyone to understand long-form videos over days, months, and year-long period. We launched our private beta on 15th of August and are opening our public playground to understand more use cases. I would personally like to thank everyone who has contributed their videos and helped us answer you better. Let's get started. I'll quickly begin with uploading a video. The video is getting processed. During the processing, we create and rich temporal database of every scene, action, event present in this video. Along with that, we also create an object database of all the objects seen in this video. This combination actually helps our agent to answer any query that you may ask to it. The processing is going to take some time. We'll wait for it to finish. The video is processed and ready for us to query with it. Let me ask a simple question. How many people are there? From our users data, we have identified that there are 95% of all the questions fall under the bucket of what, when, and how many. We never waste resources on reinferencing the video once you ask a query to it. The agent always leverages its object memory and temporal memory to find out the most relevant answer to your question. The agent says that there are 31 people in this video. Let's see how it came up with the number 31. Yep, like I mentioned, it went to the object memory and queried how many people were there, and it found that there are 31 instances of persons seen in this video. We can ask about different things as well. Let me ask, what are people wearing in this video? Comparing it to a LLM, I find it different in two ways. LLMs don't have a memory of their own, and the primary job of an LLM is to think faster and reply back faster. Well, that works for certain applications, but for videos, you need to understand the whole sequence of events that are happening and have a memory of each and every action, object seen inside the video. That's when it truly is able to understand the video and answer you back. If we ask an LLM how many people are there, it would never be able to count the number of people in it. We'll wait for the answer to come back. Yep, the LLM replies back saying that people in this video are wearing various outfits. One man is wearing a black shirt and a hat, another man is wearing a white shirt and a white hat, a woman is wearing a purple shirt and a white hat. There are lots of white hats in this video. We can ask about random things as well. Let's say I want to know the population density in this video. I can ask, what is the highest population density in this video? And let's ask it to answer back at which segment it thinks that there is a highest population density. Which segment is it in the video? Our focus is on combining video LLMs and computer vision models, the traditional computer vision models, and combine them with a strong, solid, robust memory so that we never need to do a reinferencing of videos and always be able to answer from these itself. On top of that sits an LLM which orchestrates the tools that are needed to be able to answer back. The agent replies back saying that the highest population density is in segment 89. That's good. How do we know? Segment 89 is referring to second minute and 58 second. We'll quickly verify that. Oh yeah, it does look like it's a crowded scene in this whole video. That's pretty good. How did it answer to this question? It went to the object memory, identified where are people available, the person category, and found out that these are all the segments where persons are available. And then it made sure that out of all these segments, which is the most populated segment, and it found that segment 89 has 20 people in it at once. So 20 people in segment 89 is the highest population density. That's great. Let's try a different question. I want to know, is anyone using a vehicle, let's say mobility device, like a stroller, wheelchair, or a scooter maybe, or let's say skateboarders, if there are any skateboarders, that would be interesting to know, or bicycles, and describe them too. It takes a moment for it to answer back. Let's wait for its reply. The answer has appeared and it says, yes, there's a man using a mobility device in the video. The mobility device is a green electric scooter. That's nice. And the way it has answered now is using its segment localization tool, where it went through the whole video and found out segments which are relevant, where it sees that there is a person using a mobility device, things like scooters, crawler, or anything else. And it found out that there is a segment where a green electric scooter was used. So that's good. We can ask about many other things. Let's say I want to know a specific person or a specific object. Then I can say, find a person in a, let's ask about white top, and track them across a few seconds. I also want to know where do they enter and when do they exit. Let's ask that as well. The answer has appeared. The agent says the person in a white top enters at segment 0 and exits at segment 119. Segment 0 is the first segment that we see. I see that there's a person appearing in this video. That's good. We could also see when did they exit. That's at 3:58. That's good. And how did it know? It went through the open vocabulary object detection. It doesn't know that what a white t-shirt is. So it used open vocabulary detection to specify and identify what a white t-shirt is or a person with a white t-shirt looks like. And that's when it identified all the segments where the person was available. Hence came up with the answer of segment 0 is when they enter and segment 119 is when they exit. I can ask it about to track vehicles as well. Let's say I want to track the cyclist in this video. I can ask it to, I can specify it to say, find the first cyclist that appears in the video. Give me the timestamp. Agent found out that the first cyclist appears at 0:131 second of the video. Let me find that out. Oh yeah, I do see a cyclist in this video. That's good. I'm really interested to know if there are any incidents in this video that need to be alerted or be known to someone to take action against. Let me ask, identify a moment that could trigger monitoring system and explain why it is an alert that needs to be alerted. It says that the moment that could trigger an alert in the monitoring system is in segment 78, where a man X drops a backpack on the pavement. This could also be seen as a suspicious behavior, potentially indicating a security threat. Oh wow, that's great. It went through a lot of segments to find the answer for this. Let's ask one more question to this. I want to know an estimation of the maximum number of people at the same time where in the video. Great. The agent replies back saying the maximum number of people visible at the same time is 20, and this peak occurs at 89, 88 and 79 segments. That's good. Lastly, I want to compare the results of our agent against ChatGPT and Gemini. I will upload the same video that we had uploaded for our agent and ask it the simple question: how many people are there? I've got GPT-5 thinking. Let's see how well it is able to think and answer back to the question. Gemini has answered back. It says it's impossible to give an exact number, and the people kind of walking in and out of the frame throughout the video. The Gemini's best attempt was to guesstimate and give a rough estimate of 40 to 50 people in this video. That's entirely wrong. ChatGPT has thought for 7 seconds and it's analyzing its answer now. GPT-5 errored out initially and redid its analysis, and then it came up with the answer that there are 3.25 people across the video. That's completely wrong. Hence, the power of combining temporal plus ObjectDB along with computer vision models and video LLMs is what makes us unique. We are not just looking at single frame, we are looking at the sequence of events that are happening in the video. This is the capability that makes us unique and different from every other language model that exists today. The infrastructure is super lightweight and is run at 1/10 the cost of running a large language model. Hope you like Lookup. Please do explore it on our public playground. Thank you.